identical bodies are containing water at an initial temperature of 30 degrees centigrade. A refrigerator operates between these two bodies until one body is cooled to a temperature of 5 degrees centigrade. If the bodies remain at constant pressure and undergo no phase change, the minimum amount of work needed per unit mass is. So in this case, the minimum amount of work is given by Cp into Ti square by T plus T minus 2Ti, where Ti is the initial temperature and T is the final temperature or the lowest temperature, and here Cp is the capacity of the fluid. So Cp is given with generally this is 4.8 kilojoule per kg Kelvin for the water, and for we'll have to find out the minimum work needed per unit mass. So here mass of the fluid is 1 kg, so that the minimum work done required is equal to 4.8 into this is 4.18 into Ti. Initial temperature is 30 degrees centigrade, that is 303 Kelvin, by, and final temperature is 5 degrees centigrade, that is 278 square, plus 278 minus 2 into 303, which gives a value of 9.4 kilojoules. So in the option, the right option is D. D is the right answer. This is 9.4, and D is the right answer. Domestic food freezer maintains a temperature of minus 10 degrees centigrade. The ambient air temperature is 30 degrees centigrade. If the heat leaks into the freezer at a rate of 1.5 kilojoule per second, then what is the least power necessary to pump this heat out continuously? So here we will have to find out the least power required to run the refrigerator. So least power comes from the ideal cycle. So here the COP of the ideal cycle or ideal refrigerator cycle is given by T2 by T1 minus T2, where T2 is the freezer temperature, that is minus 10 degrees centigrade, and it is equal to 263 Kelvin, and T1 minus T2 is 30 minus of minus 10, that is 30 plus 10, which gives a value of 6.575. So this is the COP of the ideal refrigerator. So from this formula we can find out the minimum work required, that is refrigerant effect to minimum work input or minimum power required. So which gives W minimum is equal to refrigerant effect by COP. Here refrigerant effect is nothing but in the problem it is given that the heat leaks into the freezer at a rate of 1.5 kilojoule per second. That means we will have to maintain, or we will have to pump out this heat at a rate of 1.5 kilojoule per second. That is nothing but refrigerant effect. So here it is equal to 1.5 divided by COP is 6.575, which gives a value of 0.23 kilojoule per second or kilowatts. So in the option, right option is A. A is the right answer. Water having cross-sectional area of 0.002 meter square moving with a velocity 20 meter per second strikes a moving plate 10 meter per second in the direction of jet. The jet makes an angle of 30 degrees with the plate. The work done per second by the jet on the plate is. So here the work done by the jet is nothing but the force exerted by the jet in the direction of jet or in x direction into velocity of the jet. And here Fx is nothing but Fn sin theta into u, where Fn is equal to rho a v minus u whole square sin theta into u. So which gives here it is equal to 1000, and it is 0.002, and it is 20 minus 10 whole square into sin 30 into 10, which gives a value of 501 meter per second. So in the options, the right option is D. D is the right answer. Atmospheric air at dry below temperature of 50 degrees centigrade enters a heating coil maintained at 40 degrees centigrade. If the air leaves the heating coil at 30 degrees centigrade, the coil efficiency would be equal to. Here, the efficiency of the coil is equal to the temperature difference between the air, that is that is the exit temperature of the air 30 minus the entrance temperature of air is 15 by the maximum difference can be occurred in the coil, that is 40 minus 15. So which is equal to 15 by 25 and is equal to 0.6. So here the efficiency of the coil is 0.6 and in the option the right option is B. 2.5 kilowatt engine has mechanical efficiency of 65%. If the frictional power is assumed to be constant with load, then what is the mechanical efficiency at 60% of the load? So here a 42.5 kilowatt engine nothing but the brake power is given as 42.5 kilowatts and has mechanical efficiency of 65%. So from these two we can find out the indicated power of the engine, that is 42.5 by 0.65, which gives a value of 65.4 kilowatts. This is the indicated power of the engine, but here we will have to find out the mechanical efficiency at 60% of the load. So at 60% of the load, the brake power of the engine is given, brake power is required is equal to 0.6 into 42.5, which is equal to 25.5 kilowatts. So here, and we can find out from these two relations the frictional power of the engine, that is 65.4 minus 42.5, so it gives a value of 22.9 kilowatts. But here the frictional power is assumed to be constant, so that indicated power required is brake power plus frictional power and is equal to 25.5 plus 22.9, which gives a value of 48.4 kilowatts, and the mechanical efficiency at 60% load is equal to 25.5 minus by 48.4, which gives a value of nearly 52.7%, and in the option the right option is C. Under petrol engine, the standard firing order is, so the standard firing order for the 4-cylinder petrol engine is 1342, that is C. 100 amp and 40% duty cycle, calculate the weld output current for 80% duty cycle. So here the duty cycle and current are related by, let us say, IR square by ID square, and let us say ID is the we'll have to find out the weld output current. So here ID is equal to IR DD by DR whole power of 1 by 2. Sorry, it is DR by DD. So which gives a value of 300 into 0.4 by 0.8 whole power of 1 by 2, which gives a value of nearly equal to 212 amps. So in the option right option is D. D is the right answer. The annual demand for a product costing 100 rupees per piece is 900. Ordering cost per order is 100 rupees and inventory holding cost is 2 rupees per unit per year. So the economic lot size is, here the economic lot size is nothing but EOQ, economic order quantity. So that is given by 2A CO by CC, where A is the annual demand and CO is the ordering cost and CC is the carrying cost. So here annual demand is 900 and ordering cost is 100 and carrying cost is 2 rupees per order, and which gives a value of 300. So in the option the right option is B. B is the right answer. Which allows the determination of the shortest route between two nodes in the given network is, here are the options: Floyd's algorithm, Dijkstra's algorithm, minimal spanning tree algorithm, and D is all of these. So all the algorithms can be used for to find out the shortest route between the any two nodes. An NC program for lathe N002 M10. M10 refers to, here there are four options: chuck open, chuck close, stop spindle, restart spindle. Here M10 refers to for a lathe program it is chuck open, and M11 refers to chuck close. So that the right option is A. A is the right answer. In a transportation problem, there are 4 supply centers and 5 demand centers. The total quantity of supply available is greater than the total demand. The number of allocations without degeneracy during iteration is, here the right answer is C, that is 9 allocations required. Keeping depth of cut constant, which of the following actions improve surface finish? Here the options are increasing cutting speed, decreasing cutting speed, increasing feed rate, all of these. So the surface finish can be improved by increasing the cutting speed, so that in the option the right option is A. A is the right answer.